Welcome back, it's me, Mr. Truman, here for another lesson in geometry. Today we're going to be looking at Pythagorean Theorem, the old a squared, b squared, c squared that everybody actually remembers about geometry, not what it's used for, but they know it's something about geometry. So when we get into this, we've been using it a lot throughout the year as a replacement for the distance formula. But now that we're actually working with triangles every day, I wanted to go over it again. I want to make sure that we understood each aspect of it. A and B are what we call legs. They are the two sides that form the 90 degree of a right triangle. I always label the leg that goes across the page as our X, and our X direction goes left to right horizontally. I call that A, and I always make sure to call B the vertical one. Whether or not that's mathematically correct, I don't know, and I don't care because it works for my students, so that's why I use it. So again, horizontal A, vertical B, and then the diagonal is our hypotenuse. So we're going to look at a few examples of this that have to do with, I'm going to look at the decimal versus radical format of answers. And before we get too far into it, I want to go over a couple of the more popular Pythagorean triples. These are sets of numbers that always make right triangles. For example, if you have a leg 3 and a leg 4, you will have a hypotenuse of 5. If you have a leg 5, a leg 12, you'll have a hypotenuse of 13. Well, to be honest, there's a neat little formula about this. There's an actual pattern. If you were to think about 3 squared, 3 times 3 is 9. Guess what two numbers add up to 9? 4 and 5. Just like, and they have to be consecutive numbers. They're always consecutive, meaning one right after the other. But if you think about another one, like 5 squared is 25. Well, what two consecutive numbers add up to 25? 12 and 13. 7 squared is 49. What two numbers add up to 49 that are consecutive? That would be 24 and 25. That's another popular Pythagorean triple. One more time, if you think about 9 squared is 81. 9 times 9 is 81. What two numbers add up to 81 that are consecutive? 40 and 41. I'm just going over a few of these because these are the ones most popular. You'll see on a lot of your assignments for my students or anybody's students, to be honest. All of these happen to start off with odd numbers. If you happen to see on a lot of tests, there's a lot of these, again, that will be using even numbers. And see if you can catch the pattern here. They're just multiplying the number by 2. You can just multiply each of these by 2 and you end up getting another Pythagorean triple that you might, again, your teacher might be using all the time on tests and on assignments. So these are just what they call Pythagorean triples. And they are just 3 sides of a triangle that always make a right triangle. All right, so diving into our first problem, I want to go ahead and use our Pythagorean theorem, and we're going to look at a problem right here, number 1, where we're going to solve for x. In this case, x is a leg. So we have our horizontal leg here, our vertical leg here, and then our hypotenuse right there at 10. So writing into the formula, I like to write a squared first. I do horizontal, then I do vertical. And then I go back and make sure to square them, not times them by 2, but square them. So that's 25 plus x squared equals 100. Trying to get x by itself, I'd minus 25, minus 25. So I get x squared is equal to 75. Well, clearly 75 is not the side of the triangle. We have to take the square root. So if we take the square root on our calculator, we get to the nearest tenth. I'm going to round it off. I have 8.66, so that would be x using square root. X is approximately 8.7. There is a second answer that I want to go over for my students. I know we've been working on this, and that is square root, reducing a square root to simplest terms. So for example, when I say 75 square root, if I want to reduce that to the simplest terms, I'm trying to find what squared number is in 75, what perfect square, and we went through this last week. Perfect squares are numbers like 5 times 5, 3 times 3, 4 times 4. Well, the number 25 is in 75, which means my answer is square root of 25 is 5. There is no square root of 3, so it's 5 radical 3. These are both legitimate answers for this question. It all depends on the application. Normally in a word problem, they want an exact answer like a decimal. But a lot of times on just practice problems, they'll say leave them as a radical. Or on things like our Florida Standards Assessment, they'll have the answer that says give it in radical form. So it all depends on the question. This is our decimal format and this is our radical format. All right, the second one I want to go over has to do with what happens in an isosceles triangle. I know this is isosceles because both legs are the same length, which means they're congruent. And these are the legs. This is your horizontal leg and vertical, and then there's your diagonal hypotenuse. Well, if I write this down as a formula, I can see that by collecting like terms, 1x squared and 1x squared would be 2x squared. And then 16 times 16 is 256. All right, well, what would I do at this point if I'm trying to get x by itself is I'm going to take that 16 times 16 and I'm going to divide it by 2. And it gives me x squared equals 128. All right, well, if I want the radical answer, I'm going to have to do a little bit more work. If I want the decimal, I'll just take my square root right now. And I'll say x is, and this is going to be rounded, so I'm going to have to say approximately. And it would be 11.3 in this case. All right, well, the other thing I would like to look at is what can I do about reducing this? Let's say I want to try to break this down. So if I have the square root of 128 and I want to use radical format, I always start by dividing by my first prime number, which is 2. So if I take 128 and divide by 2, I happen to get 64. And that's super because the square root of 64 is 8. It's a perfect square. 8 times 8 is 64. So I can cross this off, write 8. And then since 2 has no, I mean, it's as low as it can go. It does not have a square root. It's a whole number. It has a decimal, obviously, but that's my answer. So again, either answer will work. Just a matter of how you're asked to present it. All right, example number 3, I didn't leave myself much space, but I'm going to go over example number 3 because this is one that messes with a lot of people. They see that radical, they get a little intimidated. So I want to use the same formula, and I want to show how I'm going to do this. I'm gonna have to write my work over here. I'm just a little bit out of sorts here as far as how my board's organized. But if I want to solve for x, this is going to be my a value because it's the horizontal, as I like to do. Again, not sure what is truly mathematically correct. And then the next one is my b value. And by the way, I got to square this. So because it's a quantity, meaning it's more than one exact number, it's a product, I'm going to put this as a square, but I'm going to put it in parentheses. Equals 12 squared. Okay, well, we went over this. We did a lot of lessons on there. We did a lesson on this. Did quite a few problems of practicing it. But if you want to take 3 square root of 5 and square it, you say, all right, well, 3 times 3 is 9. And square root 5 times square root 5 is actually 5 because 2 roots make a whole. So square root of 5 plus x squared equals 144. 12 squared. Well, 9 times 5 is 45. So I need to minus 45 from both sides, and it gives me x squared equals 99. So again, I'm going to go back to that same thing. If your teacher wants you to go ahead and do it as a decimal, or the question asks you for a decimal, the answer would be approximately, square root of 99 is approximately 9.9. 9.94 to be exact, but we only want, I'll go to 10. If I have to reduce it though, let's think about 99. What square root is in 99? Well, that would be 9 times 11. And the square root of 9 is 3 with a radical 11. All right, so our last and final question is I'm going to do an application problem. I want to just go over how to apply this in more of a real life situation like softball field. The softball field is in the shape of a square. if the distance between the bases is 60 feet, how far is it from the pitcher? How far is the pitcher from home plate? Well, let's draw it out like we know that we see it. Let's draw, they always call it a baseball diamond, which drives me nuts because it's not a diamond at all. It's a square, completely a square. And so we have home, 1, 2, 3, and our pitcher sits right here in the middle. All right, well, if I know that these are each 60, then if I divide this baseball diamond or square like it is, if I divide it from right down here from second base to home, that becomes my hypotenuse. And so I've got 60 squared plus 60 squared equals my c squared. Well, let's see, that's 3,600 plus 3,600 equals c squared. All right, add them together. 7,200 equals, or square root, equals c squared is 84.8 feet from home to second base. I just want to know where the pitcher's at. So how far from home plate to the pitcher? Just divide it by 2. And I get approximately, in this case, 42.4 feet. All right, well, I hope that helps you figure out a little bit more on how to do Pythagorean theorem. And that's it for this video. Bye-bye.